Welcome to part 2 of your Unit 1.8 Acids, Bases and Salts videos, where we will be looking at the reactions of acids. So if you turn to page 10 for this video. We are going to be looking at some specific reactions of acids, for example the reaction of acids with metals, metal oxides and hydroxides, metal carbonates and hydrogen carbonates, and ammonia. But before we look at those specifically, there are some general observations that we can observe. For each of those 4 categories of reactions, we will look at the observations in turn. But rather than learn them all off by heart, it's helpful to go into the reactions by knowing what you're looking out for in terms of the observations. What are you expecting to see? So this is probably easiest looked at in this first example in the first bullet point. If you have a gas produced in your reaction, then you will observe fizzing or bubbling or effervescence. You can refer to any of those, but you'd only get 1 mark. You wouldn't get 3 marks for saying fizzing, bubbling and effervescence, because they all mean the same thing. And that's because you've got a gas being produced in a solution, so obviously you're going to see bubbles rising up. If there's a solid used in your reaction and it reacts with the acid, what will happen is the solid will disappear and it will form a solution. Now that solution may be coloured, and we'll come back to that in the 4th bullet point. Most acid reactions, when they react, they release a lot of heat, or in other words, they're exothermic. We'll meet that term again next year. And what we write down as our observation is heat is released. So if you've got a reaction of an acid, you can assume heat is released. But there are 2 exceptions that you need to be familiar with. The reaction of copper oxide with acid does not release heat. And the reaction of sodium or potassium hydrogen carbonate with acid does not release heat either. In fact, it's what we call an endothermic reaction. It takes in heat and the temperature will actually drop. And we'll see that later on when we look at that specific reaction. So keep those 2 in mind as exceptions, but otherwise, if you see a reaction of an acid, you can just write down the observation, heat is released. And then coming back to that idea of the colour change, acids are always described as colourless. If you think of sulfuric acid, hydrochloric acid, they're all colourless. But sometimes the solution we get at the end is a coloured solution. And the most common one to be formed is a copper salt in solution. Copper salts in solution are blue. And you should be familiar with these from Unit 1.6, but the table below gives you a list of chemicals that are coloured, and you need to be familiar with their colours. So we'll fill those in now, but you should be able to fill them in from Unit 1.6. You should be familiar with them. So if you want to pause the video and try to fill out the table yourself, you can do. But copper oxide, which we'll see later on as well, is black. It's a black solid. Copper carbonate, again we'll meet this later. But you should remember from Unit 1.6, it is a green solid. So those are the 2 copper compounds that don't fit the normal rule of copper being blue, copper salts being blue. Hydrated copper sulfate, you should remember, is are blue crystals. That word hydrated just means they contain water within their structure, so that's what makes them crystal form. Copper salts in solution, that means they're dissolved in water, that they lead to a blue solution. Okay, group 1, group 2 aluminium or zinc compounds. What we mean by that is the likes of sodium chloride. So you could write that down as an example. And why that's a group 1 compound is because sodium is in group 1, but it's also reacted with chlorine to make sodium chloride. It's a compound, it contains more than 1 element. So it's sodium chloride. Sodium is in group 1. So that means that all group 1, group 2 aluminium or zinc compounds are white solids. So try and think of some other examples. Group 2 compounds, so that would be the likes of magnesium If we number this, maybe number 5. More examples: magnesium bromide. Zinc compounds, you could have zinc oxide, which you met in your nanoparticles topic. Aluminium compounds, things like aluminium chloride. Okay, so all of those compounds would be white. When we dissolve those compounds, so when we dissolve compounds of group 1, group 2, aluminium or zinc, the ones we've just been talking about, they dissolve in water to give you colourless solutions. Have a think about it. The first example we looked at, sodium chloride, that's just table salt. So even if you can remember that one example, that would help you remember the colour of group 1 compounds. So sodium chloride is just table salt that you put on your dinner. You know that it's white, and you know that if you dissolved salt in water, it would give you a colourless solution. So be familiar with those general observations as we work through the rest of the topic. For each reaction that we study, we will look at a general equation, and what we'll see with those general equations is that every single time we react either a metal or metal oxide or metal carbonate with acid, they all produce a salt. Every single reaction produces a salt, and you need to know the definition for a salt. And that's new to the course this year, but basically we'll look at some examples to make this a little bit easier. But a salt is a compound formed when some or all of the hydrogen ions in an acid are replaced by metal or ammonium ions. So remember we talked about how in the last video all acids dissolve in water to give you H+ ions. So we looked at hydrochloric acid dissolving in water to give you H+ and your chloride ion. We talked about sulfuric acid dissolving in water to give you 2 hydrogen ions because it's H2, and your sulfate anion. So what we're saying is that those hydrogen ions that I've written in green, when they form a salt, they are replaced by metal ions or ammonium ions. So it is those that bond up with your anions, so the likes of your chloride or your sulfate. So let's have a look at a few examples here, and I'm going to draw my hydrogen ions in different colours. So it says magnesium sulfate is the salt formed when magnesium ions replace the hydrogen ions of sulfuric acid. So I can tell it's a salt of sulfuric acid because it ends in sulfate. So if we have a look at the formula of sulfuric acid, I'm going to draw my hydrogen in a different colour to make it stand out. So sulfuric acid, and you need to be familiar with this formula, is H2SO4. Magnesium sulfate forms when my magnesium ions replace the hydrogen ions. So those 2 hydrogen ions are replaced by magnesium ions, MgSO4. Now, you may be wondering why there are 2 hydrogen ions, but there's only 1 magnesium ion. But if you look at the charge here, the charge of magnesium is 2+, whereas the charge of hydrogen is just 1+. So because sulfate is SO4 2-, we needed 2 hydrogen ions to cancel that charge out, but we only need 1 magnesium ion. But we'll come back to that when we're looking at formula, so don't worry too much about that for now. Potassium sulfate now. Again, if we look at the formula of sulfuric acid, H2SO4. Potassium this time has replaced hydrogen ions, and it has the same charge as hydrogen ions, so we're going to need 2 of those as well. So K2SO4. You can see that the 2 hydrogen ions have been replaced by potassium. Ammonium sulfate may be something you're not just as familiar with, but ammonium ions, they're on the back of your periodic table, NH4+. They should not be mixed up with ammonia, which is NH3. And we'll be coming back to that later on. Ammonia is NH3. So don't mix ammonium ions with ammonia. You can see that ammonium ions have an extra hydrogen ion. So ammonium sulfate is formed when ammonium ions replace your hydrogen ions. So again, if we look at the formula of sulfuric acid, those hydrogen ions that I've drawn in green are replaced by ammonium ions. Again, you can see that ammonium ions have the same charge as hydrogen ions. So I need 2 of them as well for my formula. So I put that in brackets because I need 2 of the whole ion. I couldn't put a 2 without the brackets. So that's NH4 2 and then SO4. So always just think of salts as the metal ions or the ammonium ions, whichever you're using, replacing the hydrogen ions within your acid. So now let's have a look before we start into the specific reactions of acids. Because they all produce salts, let's have a quick look at how we name those salts so that we're ready to do that when we look at the specific equations. The rules are always the same. The first part of the name of a salt, and you'll remember this from the previous page, we looked at, say for example, magnesium sulfate. The first part of that name, magnesium, obviously comes from the metal that we used. So the first part of the name comes from the metal or the metal compound. If we're using a metal compound, say for example magnesium carbonate, we just drop the carbonate part. It's always just the metal itself, and that's the second bullet point. The name of the metal remains unchanged. So magnesium just stays up as magnesium. But the second part of the name, sulfate, you can have a think, what does that sound quite like? Well, it comes from sulfuric acid. So that means the second part of the name of a salt always comes from the acid that is used, but its name does change. So it's not magnesium sulfuric, it's magnesium sulfate. And that acid name always changes to the same thing each and every time. So you can see that here in the second point. Sulfuric acid gives you sulfate salts. That's the second part of the name. Hydrochloric changes to chloride. That's probably the one people mix up most often, because they maybe say hydrochloride rather than just chloride. So it's hydrochloric, changes its ending to chloride. Sulfuric, the second part of the name will be sulfate. And if we use nitric acid, the second part of the name of your salt will be nitrate. So always think of salts as having 2 names. First part of the name comes from, or the first name comes from the metal. Second name comes from the acid. So we will also need to be able to write the formula of salts. So to bear that in mind, we need to know the formula of these second part of the names. You should also be familiar with the formula of the acids, which we talked about earlier. So hydrochloric acid is HCl. I'll put my hydrogen ions in a different colour again. Sulfuric acid is H2SO4. And nitric acid is HNO3. So you need to be familiar with those formulas for writing equations. It's very common to get asked to write a balanced symbol equation for these types of reactions. And actually, what I've drawn in purple in the formula forms the ending of the formula of our salt. So you see the way hydrochloric acid gives us chloride salts. Well, we know the formula of a chloride ion is Cl minus, just as I've written here in the formula of my hydrochloric acid. That means when we are writing the formula of our salts and we're doing swap and drop with the name of the metal, I'm using chloride, it's Cl, and because I've got a minus sign, that means I have a valency of 1. So chloride has a valency of 1, and sometimes it's worth just learning those to help you when you're writing formula. Sulfate salts, remember that sulfate, if you look at the back of the periodic table, it has a formula of SO4, just like in my sulfuric acid, but then we need to think about the charge. You can either learn that sulfate has a charge of 2 minus, or you can look on the back of your periodic table. It will always be given to you. So when I'm doing my swap and drop with sulfate, it has the formula SO4 and it has a valency of 2, and we may need to use brackets for that. Nitrate then, with nitric acid, we get nitrate salts, and again from the formula of nitric acid you can see that the formula of nitrate is going to be NO3. Because it only has one hydrogen, it just has a charge of minus. So again, when we're thinking about doing our swap and drop, it's going to be nitrate NO3 with a valency of 1. You need to be familiar with those, but essentially if you learn the name changes, hydrochloric acid gives you chloride, sulfuric acid gives you sulfate, nitric acid gives you nitrate salts, and then you can find the formulas from your periodic table. But it's helpful to be familiar with them so you can go straight ahead and do your formula. So we're given some examples of metals or metal compounds and acids, and we're asked to name the salt and we're asked to write the formula of the salt. So first of all, sodium and hydrochloric acid. Let's think of the name of the salt produced. Well, the first part of the name comes from the metal and it remains unchanged, so it's going to be sodium. Second part of the name comes from the acid, but it changes. So it's hydrochloric acid, and we can see from up above that hydrochloric acid changes its ending to chloride. So you can see the name of my salt is sodium chloride. Now I have to write the formula, and we do this by swap and drop. So remember, when we're doing our swap and drop, we write down the formula of our substances. I don't have room to work underneath, but I'll work off to the side here. So sodium is Na, chloride is just chlorine, Cl. Then I work out my valencies. So look to the top of the group for sodium. We can see that its valency is 1. Chlorine is in group 7, so it also has a valency of 1. I can't cancel those down at all, they're already in its simplest form. So I swap and drop, and because I'm swapping down ones, I'm going to end up with my formula simply as NaCl. Copper oxide and nitric acid next. So remember, the first part of the name comes from the metal or the metal compound. So our metal compound is copper oxide, but I don't include the name of the second part of the metal compound. It just comes from the metal and it remains unchanged. So your metal is copper, so the first part of the name is just copper. Second part of the name comes from the acid and it changes its ending. So look up above, nitric acid changes to nitrate. Copper nitrate is your salt. So now looking at writing the formula for copper nitrate, we need to convert it to its formula first of all, and we need to be careful here because we've got nitrate, which is a molecular ion. So let's write our formula first of all. So it's copper, which is Cu, and it's nitrate, which we can see from up here, is NO3. But because this is a molecular ion, I'm going to need to put it in brackets, because any number I swap down from the copper will need to go outside those brackets. So copper is a transition metal, therefore I can't get its valency from its group number. And quite often it would be given to you as Roman numerals after copper, but it's not in this case. So if that is the case in the exam, look to the back of your periodic table, and you should have it in front of you at the minute. But if not, get it out and have a look at the yellow box if you're looking at your coloured version, or the left hand box in which says positive ions. Look down to copper, you can see it's copper 2 and it has a charge of 2+, which means its valency is 2. So that may have been given to you as copper brackets 2 oxide. So the valency of copper is 2. Have a look up here again. Nitrate has a charge of minus, so its valency is just 1. And you can see I can't cancel those down at all, they're already in their simplest form. But when I swap and drop them, we find that the formula of my copper nitrate is going to be Cu brackets, then my nitrate, NO3, close your brackets, and then the 2 that I have swapped down from my copper. So Cu brackets, NO3 brackets 2. You need to include your use of brackets, otherwise that 2 wouldn't apply to the whole nitrate ion, and you need to remember about including your 3. Okay, let me do one more example with you, or if you feel ready, pause the video and try the next ones and see how you get on, and then check the rest of the video to see if you're correct. So the next one we've got is magnesium carbonate. Have a think what the salt would be called. Okay, remember, first part of the name comes from the metal, which is magnesium. Second part of the name comes from the acid. Sulfuric acid changes to sulfate. It's going to be magnesium sulfate. Have a go at trying to do your swap and drop, and then I will go through it with you. Okay, so converting magnesium to its formula is Mg. And converting sulfate to its formula, well, again, if you look up above, we have written the formula. It's SO4, or you can look at the back of your periodic table. But please remember, it's SO4. Don't forget that little 4 and just write SO. Time for our valencies now. Magnesium is group 2, so it has a valency of 2. Sulfate has a charge of 2-, so as we said before, it also has a valency of 2. You can see that I've got a ratio of 2 to 2 here. So that can actually cancel down to 1 to 1. Now when I was writing my sulfate, to keep myself right, I probably should have written brackets around your sulfate. But what we'll see with this example is I don't actually need them. Because when I cancel that ratio down to 1 to 1, I'm really just swapping down ones. And I'll do it the long way for you here. So what I would end up with is Mg brackets SO4, because I can ignore my ones because I don't include ones in my final formula. And once we've got down to that stage, because we have no number outside the brackets, it's just Mg SO4. So when there's no number outside the brackets, we don't need to include those brackets. Okay, pause the video now and have a go at example 4 and 5. See if you can name the salt and write the formula, and then I'll go through the answers with you. But do have a go yourself. It's important that you're able to do this without guidance. So for potassium hydroxide and nitric acid, again, first part of the name from the metal, second part of the name from the acid, you're going to end up with potassium nitrate. Then thinking about our formula, well, we've got potassium, which is K, we've got nitrate, which is NO3. And we will put brackets around our nitrate just in case we have a number to swap down. Potassium has a valency of 1. Nitrate has a charge of -, so it also has a valency of 1. So when I swap and drop those, I can ignore the ones, and then because I don't have any number outside the brackets, my formula is just going to be KNO3. Alright, and then lithium and sulfuric acid. My salt is going to be lithium, and then sulfuric acid changes to sulfate. Lithium, sulfate. So looking at my formula, lithium is Li, sulfate is SO4. I'll put brackets around it because it's a molecular ion, just in case. Working out our valencies now, lithium has a valency of 1. Sulfate has a valency of 2. So when I swap and drop those, I'm going to end up with Li from my lithium, then the 2 that I swapped down from my sulfate, and then because I'm swapping a 1 down from my lithium, I don't need to include the brackets, but I'll just do that the long way just to show you. It would be SO4, and then I've swapped my 1 down from my lithium. I can ignore the 1 because I don't include ones in my final formula. So it would be Li2 brackets SO4. And then because there's no number outside the brackets, I don't need to include the bracket. So it would be Li2 that was swapped down from my sulfate, and then SO4 would be your formula. So you need to be confident in those. So give yourself some more practice. Think of a metal and think of an acid and try naming your salt and then writing the formula. That's us at the end of the second part of this topic, the second video. The remaining videos will look at specific reactions of acids. So reaction of acids with metals, metal oxides and hydroxides, metal carbonates and hydrogen carbonates, and with ammonia.